In October 2018 and March 2019, two brand-new Boeing 737 MAX aircraft, Lion Air Flight 610 and Ethiopian Airlines Flight 302, plunged from the sky within 5 months of each other. A total of 346 lives were tragically lost. These were not isolated incidents, they exposed a deeply troubling flaw in one of the most anticipated commercial aircraft in modern history. Initially, Boeing deflected, hinting at pilot error. But as investigations unfolded, a far more systemic and alarming picture began to emerge. The real cause lay hidden in plain sight, a story of compromised safety, intense commercial pressure, and critical failures of oversight. Following the first crash, Boeing's initial public stance was to attribute the incidents to pilot actions, suggesting that operators might not have correctly handled the aircraft. This narrative quickly crumbled under scrutiny. Boeing CEO Dennis Muilenburg was eventually compelled to testify before Congress, a stark indicator of the gravity of the situation and the public distrust that had taken root. The company's attempts to shift blame only intensified the investigation, compelling regulators and the public to dig deeper into the aircraft's design and certification process. At the heart of the catastrophe was a system unknown to most pilots, the Maneuvering Characteristics Augmentation System, or MCAS. This automated flight control system was designed to operate largely in the background, without direct pilot input or awareness in most operational scenarios. Its existence and function were intentionally downplayed, even omitted from pilot training manuals. MCAS became the ghost in the machine, an invisible force capable of overriding manual control, turning what was meant to be a safety feature into a deadly instrument of disaster. The need for MCAS stemmed from a critical design compromise. Boeing decided to adapt its aging 737 airframe for the more fuel-efficient, larger engines needed to compete with Airbus. These larger LEAP engines were positioned further forward and higher on the wing than previous models. This change, while economically beneficial, significantly altered the aircraft's aerodynamic characteristics, particularly at high angles of attack. The plane developed a tendency to pitch up during certain maneuvers, an unfamiliar trait for 737 pilots. MCAS was conceived as a software patch to subtly mimic the handling characteristics of older 737s. The fatal flaw of MCAS became apparent when it received erroneous angle of attack, or AOA, sensor readings. An AOA sensor measures the angle between the wing and the oncoming air. If a faulty sensor indicated the plane was stalling even when it wasn't, MCAS would activate. Believing it was correcting an imminent stall, the system repeatedly commanded the horizontal stabilizer to push the aircraft's nose down. This happened with such force and persistence that it effectively overcame the pilot's attempts to manually regain control, leading both planes into unrecoverable dives. A critical design oversight was MCAS's reliance on input from a single angle of attack sensor. While the 737 MAX was equipped with two AOA sensors, MCAS was designed to take data from only one at a time. This created a single point of failure. If that single sensor failed and provided incorrect data, MCAS would activate, regardless of the reading from the second, perfectly functioning sensor. This lack of redundancy, a fundamental principle of aviation safety, turned a minor component failure into a catastrophic system-wide collapse. The potential for such a singular failure to trigger a fatal sequence was tragically overlooked. The Federal Aviation Administration, or FAA, plays a crucial role in aircraft certification, yet a key aspect of this tragic saga was its extensive delegation of safety certification tasks directly to Boeing. In an effort to streamline the process, the FAA allowed Boeing engineers to review and approve significant portions of its own aircraft's design, including complex systems like MCAS. This practice, while common, dramatically reduced independent oversight, turning what should have been an adversarial safety check into a collaborative, and ultimately compromised, exercise. The watchdog became too close to the entity it was meant to regulate. Compounding the issue of delegation was the FAA's own internal struggles. The agency faced a severe shortage of qualified staff and an insufficient budget for independent oversight of the ambitious 737 MAX program. This meant that even the delegated reviews were not adequately scrutinized. With limited resources, the FAA couldn't thoroughly challenge Boeing's assertions or delve into the intricate details of systems like MCAS as deeply as required. This created a dangerous vacuum, where crucial design elements and potential failure modes went unnoticed or unchallenged by the primary safety regulator. Underpinning these technical and regulatory failures was an intense commercial rivalry. Boeing was locked in a fierce battle with its European competitor, Airbus, specifically against the highly successful Airbus A320neo. To compete, Boeing needed to bring the 737 MAX to market rapidly, prioritizing speed of certification over exhaustive safety testing. The pressure to deliver planes quickly and minimize costs became a major driver. This environment incentivized shortcuts, including the controversial decision to minimize pilot training requirements, further compromising safety margins for the sake of market share and profit. Perhaps one of the most damning revelations was that Boeing intentionally withheld crucial information about MCAS from pilot manuals and training programs. The company actively chose not to inform pilots of the system's existence, its function, or how to counteract its activation. This decision was driven by the desire to avoid the need for costly simulator training, which would have delayed deliveries and increased operational expenses for airlines. Pilots, who believed they were flying a slightly updated version of a familiar aircraft, were unknowingly at the mercy of a powerful, undisclosed system with potentially deadly consequences. The financial implications of mandating simulator training for the 737 MAX were substantial. Boeing estimated that such training would have cost airlines millions of dollars per operator, and significantly delayed the delivery of new aircraft. Each simulator session would incur expenses, and the logistical challenge of training thousands of pilots worldwide would be immense. By classifying the MAX as simply another variant of the 737, requiring only minimal, computer-based training, Boeing made the aircraft more attractive to buyers. This cost-saving measure, however, came at the ultimate price of human lives, proving to be a catastrophic miscalculation. This deliberate omission left pilots completely unprepared to handle an MCAS malfunction. When the system began to relentlessly push the nose down, pilots were confronted with an emergency that defied their training and experience. They had no procedural knowledge of MCAS, nor any specific checklist to follow. The frantic struggle in the cockpit, captured by flight data recorders, showed them desperately trying to counteract an unknown force. This lack of awareness and preparedness transformed a solvable technical glitch into an insurmountable crisis for those at the controls, sealing the fate of the passengers and crew aboard both flights. The issues extended beyond software design and regulatory oversight, reaching into Boeing's production culture. Boeing engineer Ed Pearson testified about immense production pressure at the company's Renton plant, where the 737 MAX was assembled. He described a chaotic environment with unaddressed defects and a focus on speed over quality, leading to exhausted workers and potential errors. Pearson's testimony painted a picture of a company where internal warnings about production quality were often ignored or downplayed, suggesting that the drive for rapid output created a breeding ground for systemic problems long before the planes ever took flight. The repercussions for Boeing were severe. In January 2021, the company entered into a deferred prosecution agreement with the U.S. Department of Justice. Boeing settled for a staggering $2.5 billion. This amount included a $243 million criminal fine, $1.77 billion allocated for compensation to airlines impacted by the grounding and delivery delays, and an additional $500 million earmarked for beneficiaries of the crash victims. This settlement, while substantial, reflected the gravity of Boeing's negligence and its systemic failures, acknowledging that the company's conduct directly contributed to the loss of 346 lives. The crashes led to an unprecedented worldwide grounding of the entire Boeing 737 MAX fleet. For 20 long months, from March 2019 until November 2020, every single 737 MAX was forbidden from flight, costing Boeing billions and severely disrupting global air travel. Beyond the financial impact, Boeing's century-old reputation as a symbol of American engineering prowess and safety was profoundly tarnished. Public trust evaporated, and the company faced a monumental task to regain credibility, a task it continues to grapple with to this day. The grounding was a visible testament to the scale of the safety failures. To return the 737 MAX to service, Boeing was forced to implement significant design changes to MCAS. The updated system now takes input from both angle of attack sensors, eliminating the single point of failure. Crucially, MCAS will only activate once per event, preventing the continuous nose-down commands that plagued the original software. Furthermore, the revised MCAS cannot override pilot control, ensuring that manual inputs always take precedence. These changes, alongside mandatory pilot training updates, aim to prevent a recurrence of the fatal sequence, but the trust in Boeing's safety culture remains under intense scrutiny. The Boeing 737 MAX tragedy served as a brutal, expensive, and ultimately fatal lesson for the entire aviation industry. They underscored the dangers of compromised regulatory oversight, the corrosive effects of commercial pressure on safety decisions, and the critical importance of transparency and thorough pilot training. The crashes were not merely a technical failure of software, they were a systemic breakdown rooted in corporate culture and regulatory capture. As air travel continues to grow, the mechanisms for ensuring aircraft safety must evolve, learning from past mistakes to prevent future catastrophes and uphold the paramount trust placed in every flight.